You're welcome to today's class, mathematical induction. Now we want to prove this mathematical induction, and we're told that the value of n is greater than or equal to 1. What this thing simply means is that the value of n, it can be greater than 1 or it can be equal to 1. You understand? Now, this mathematical induction, you notice this is n at the left hand side here, and this is what we have as equation at the right hand side. This equation at the left hand side is what they use to derive each of these. That is, if your n equals to 1, it will give you, if your n equals to 1, it will be 1. If your n equals to 2, it will be 2. If your n equals to 3, it will be 3. So this is used to derive the term, each of these term at the left hand side here. So mathematical induction, it has 3 major steps. The first one is to say let your n equals to 1. You say let your n equals to 1. The second one is let your n, that is you assume, this second one is you assume that your n is equals to k. Why the third one is to do what? Is to let your n equals to what? K plus 1. These are the 3 major steps we need in mathematical inductions. Okay, so let's come back to this proving. Now, we said the first one is to do what? Let your n equals to 1. That is, let n equals to 1. Now, if n is equals to 1, I will substitute the value of 1 into the equation at the left, and the equation at the left is what? At the left hand side, we have what? N. So if your n equals to 1, what will it give you? That is equals to what? 1. That is, if your n equals to 1, if you replace this to be 1, it will still give you 1. So which is exactly the same thing as this. But at the right hand side, this is the equation we have at the right hand side, which is n into bracket n plus 1 all over 2. So if I say my n equals to 1, this n equals to 1, I will substitute it at the left, at the equation at the left. I will substitute it at the equation at the left. So I will also substitute it at the equation at the right. So this is the equation we have at the left, which is this. So when I put 1 here, it still gives me 1. And at the right, this is the equation we have, which is this. So I want to substitute n to be equals to 1 into this equation, whether it will also give me what? 1. So if I write 1 into bracket, this will become 1 plus 1, close the bracket, all over 2. So this gives us 1 into bracket. 1 plus 1 is equals to 2 all over 2. So this gives us 2 times 1 will be 2 over 2. That is equals to 1. So we can see that our left hand side, our left hand side is equals to the what? The right hand what? Side. Okay. Then we can proceed to the next step. And the next step says that we let n equals to what? K. But here, as I've said, that you assume that your n is equals to k. Now, coming back to what we have at the left hand side, this is what we have at the left hand side, this is what we have at the right hand side. So I will replace, anywhere I find n, I will place it with what? With k. So this gives me 1 plus 3 plus 2. I want to write this 1 plus 2 plus 3 plus up to n. Now I will not need to write n because I'm replacing n at the second steps. I'm replacing n to be equals to what? To be equals to k. So I will write k here equals to. So at the right hand side, I will replace n with k. So that gives me k into bracket k plus 1 all over 2. So this is the second step. This is the second step. We are done with the second step because we can't prove further because we assume. You understand? So we assume. We can't prove this one further. So we need to jump to the third step. So the third step, which is the proving, let's say, okay, the third step says let n equals to what? N equals to k plus 1. So anywhere I find n at the left hand side, I will replace it with what? With k plus 1. And at the right hand side, I will replace n with what? With k plus 1. So at the left hand side, I have 1 plus 2 plus 3 plus dots plus. Now, next step is to replace n equals to k plus 1. But before I do that, check the last one I did there. I replace n to be equals to what? K here, which is this. So I will need to write this first before I will now substitute n equals to k plus 1. So I will need to write this, which is k plus. Now I will now replace n with what? K plus 1. This n, I will replace it with k plus 1. That will give me what? k plus 1. At the right hand side now, what will I have at the right hand side? This equation for the right hand side, we have what? This one will change to k plus 1. That will give us k plus 1, open bracket. This one will change to k plus 1. K plus 1. But mind you that we have another plus 1 here. Plus 1, close the bracket, all over what? All over 2. Okay. So here we have this gives us 1 plus 2 plus 3 plus k plus bracket k plus 1 equals to k plus 1 bracket k. 1 plus 1 will give me what? Plus 2. Everything all over what? All over 2. But now, if you look at this carefully, if you look at this very well, you will see that from here to here is the same thing as from here to here, right? Whatever we have from here to here is the same thing as what we have from here to here. And from here to here is equals to what? This, right? So therefore, from here to here will be equals to what? This. This one still remain. We want to substitute from here to here to be equals to this, because from here to here is same thing as from here to here. So it will give us k into bracket k plus 1 close bracket all over 2. I've replaced from here to here with this. I will continue with the rest, plus k plus 1 all equals to k plus 1 k plus 2 here all over 2. Now what I want to do here is that I want to make sure that our left hand side is equals to the what? The right hand side. So we want to prove it that our left hand side is equals to the right hand side. So let me jump to this step. Now here we have k plus 1. Let me write it here, k plus 1. Sorry, k into brackets k plus 1, k into bracket k plus 1 all over 2 plus k plus 1 equals to k plus 1 into bracket k plus 2 all over 2. Now let's prove it, our left hand side to be equal to the right hand side. So from our left hand side, this is like the same thing as over 1. Okay, so I will now find the LCM of 2 and 1 is what? Is 2. So let's do it like this. Here we have 2. I want to prove this left to be equal to this. So here I have 2. 2 divided by 2 is what? Is 1. If I use 1 to multiply all this, it will still give me this. So here I have k into bracket k plus 1 plus. Now, how many times does 1 goes in 2? That is 2 divided by 1. It will give me what? 2. So I will now use the 2 to multiply this. So it will give me 2 into bracket k plus 1. Right? Okay. If you look at this very well, you see that what something is common here is also common here. And what is that thing? K plus 1 is common here. K plus 1 is also common here. So I will bring it out. So once I bring k plus 1 out, if I bring k plus 1 out here, I'm left with what? K. I'm left with k plus. If I bring k plus 1 out here, I'm left with what? 2. Everything all over what? All over 2. So here I have k plus 1. This is equals to k plus 2. Everything all over 2. Now you can see that I've proved the left hand side to be equal to what? To the right hand side here. The left hand side to be equal to the right hand side. Therefore, since the left hand side is equals to the right hand side, therefore the mathematical induction is what? Is true. It's true. Please consider to subscribe for more tutorial videos. Do it to like and share to your friends. Thank you.